Okay, in this video I want to talk about theory of evolution. Now, I'm going to be moving from genetics to evolution, the second part of this unit. So, what's the theory of biological evolution? Now, the theory of biological evolution is basically a theory regarding any genetic change in a population that's inherited, okay, over several generations. Okay, so biological evolution states, the theory of biological evolution states that life on Earth has changed over time and also I should mention that excuse me, gradual development of different species came from a common ancestor. Okay. Any genetic change in population inherited over several generations. Okay, the changes may be small, they may be large, or not so noticeable. So that's the theory of biological evolution. Now, what's a theory in scientific terms? So a theory in scientific terms, okay, it's basically a collection of hypotheses. Hypotheses is a plural for hypothesis that have been tested and supported consistently. That's a word, important word. Consistently by available evidence. Okay, so it's been tested against evidence, basically, these hypotheses. Okay, scientific theories are concerned with what's observable, what's measurable, and testable, and they're basically subject to change on a regular basis. Okay, and if they're wrong, they're basically tossed out of the window. So that's evolution theory. We'll now talk about the work of Lamarck, Darwin, and Wallace. Okay, these are basically evolutionists. Now, until the late 1700s, most scientists believed that different types of organisms and their characteristics were fixed. Okay, they didn't evolve; they were fixed for all time. The first detailed account of how species could change and evolve came from a French naturalist named, let's see if I can get this right, Jean-Baptiste. It's pronounced Jean-Baptiste Lamarck. Okay, and he basically spent many years classifying plants and animals called invertebrates. And vertebrates, basically animals without a backbone, okay, or without a bony skeleton, like worms. Okay, worms are invertebrates. And he basically thought that the similarities. So he thought that the similarities and differences between living things made sense, okay, only if the species were evolving. And he supported evolution, Lamarck. Can you believe that organisms were guided through their lives by a creative force, okay, that enabled them to overcome the environment and its harsh conditions, okay? And he had no experimental evidence, I should mention. No experimental evidence for any of these claims, okay? He just hypothesized evolution should exist. That's Jean-Baptiste Lamarck. In a nutshell, also I should mention before moving on, so Lamarck thought that characteristics were passed on to the offsprings, okay, from the parents to the offspring. Okay, and their organs either improved or weakened For example, a longer neck on a giraffe, okay, was passed on from generation to generation. Now, modern genetics, however, proved him wrong. It wasn't characteristics that could be inherited, all right? It's genes. So that's Jean-Baptiste Lamarck. Then we're going to talk about Charles Darwin. I'm sure everyone's heard of Charles Darwin. Charles Darwin, he was an English biologist. Okay. He abandoned his studies in medicine and religion. He went to follow his career. A career as a naturalist. Right. At 22 years old, he actually went on a ship for an expedition to chart the coast of South America. Okay. And the next 5 years after that, he spent observing the geographical distribution of plants and animals, rocks and stuff in various places around the world. And he became convinced. While exploring the world, became convinced that species could develop from a common ancestral type, I should say. And some of his most important observations were on wildlife, on his expedition. On his trip to the Galapagos Islands. And these are basically about 1,000 k's off the coast of Ecuador in South America. He observed wildlife there, and there were islands. The Galapagos Islands are basically islands that are isolated from one another, okay, by strong ocean currents. And he noted some similarity between the island organisms, okay, and the mainland organisms. Okay, the most famous of the island's organisms are finches, okay, and they're now known as Darwin's finches. Finches are little birds. Darwin's finches was an important work that he did. He studied finches on the islands, and he found 14 species of finches. They were all similar in color, in their calls, in their nests, and their eggs, but they were different, obviously, in their habitat and their diet and body size, etc. So different in their habitat, diet, and body size. And he believed that they came from a common ancestor. And then he proposed the process of natural selection to explain it. And I'll explain that in subsequent videos. Basically, nature selecting the best of the species. So that's Charles Darwin in a nutshell. We're now talk about Alfred Russel Wallace. He was another British naturalist. Okay, and he developed his own theory of evolution, actually. Published a paper on the origin of species, okay? And that made Darwin realize how close Wallace's work was close to his. So Darwin and Wallace were pretty much similar in their views. And he said that evolution occurs by natural selection. Okay, and he published, he jointly means with someone else, so he jointly published a paper with Darwin. The paper is a scientific piece of work, right? You do an experiment, you write about it in a paper. So jointly published a paper with Darwin in 1855. Okay. So that's Alfred Russel Wallace is pretty similar to Darwin. That's why I didn't really worry much about him. Allow me to draw a timeline of the history of the theories of evolution. Okay. Of history of theories of evolution. Okay, to give you an idea of how far we've come in our understanding, well, at least some of us in our understanding of the world. We draw a massive line. So a timeline works by a massive line, a continuous line. Put some dates here: 1750, 1800, 1850, and 1900. Now let me use different colors for this. Okay. The first was a guy named James Hutton. Okay, in 1785, so around here. James Hutton. And he proposed that the Earth was shaped through geological forces. Okay. Through geological, so through the Earth's movement, say, geological forces, okay, that took place over millions of years. So that's James Hutton. But then in 1798, about here, a guy named Thomas Malthus, okay, he predicts that human population will grow faster than the amount of resources that can accommodate them, okay? 1798. In 1809, okay, as I mentioned, Jean-Baptiste Lamarck, he was one of the first to propose a mechanism or something explaining how organisms change or evolve over time. Okay, so that's Jean-Baptiste Lamarck. Then we had 1850. Sorry, not 1850, 1858. We had Wallace, Alfred Wallace. Okay, he writes to Charles Darwin on natural selection based on his own studies. That's 1858. 1859, very closely following, soon after, Darwin publishes his famous book called On the Origin of Species. On the Origin of Species. So it was 1 year after Wallace. Okay, and that's basically it. That's the timeline of the theories, different theories of evolution. So let me now briefly talk about Darwin, as he's the most celebrated evolutionist. Now, Darwin didn't actually know about genetics, okay? So Darwin didn't know about genetics. Okay, why didn't he not know about genetics? Because it wasn't discovered at the time. Okay, people couldn't see what DNA was. They didn't know what it was. He also didn't know species. He didn't also know sources of variations. Also didn't know sources of variations. Okay, but he knew that variations had to be present for natural selection to operate. So variations are differences in things, right, in species. So Darwin then concluded that natural selection could only act if there is variation and natural differences in the population. Okay, and since then, scientists have shown that variation is caused by differences in genes. Okay, so differences in genes nowadays, genes are parts of DNA, which result in different characteristics. Okay, which equals different characteristics. Okay, and variation in most organisms is easy to see. Okay, so humans show variation in their height, in their hair, in their skin color, etc.